This conference will now be recorded.
Appreciate the learning officers' involvement as well as the GOES-R and the JPSS program. So I'm going to introduce YJ now so we can get started. After her completing her PhD in meteorology at Florida State, she joined CIRA in 2006 and has been working on satellite-based cloud and precipitation measurements as a research scientist. Her recent research interests are cloud height and cloud layer retrievals using active and passive satellite data and mixed phase cloud studies. YJ gave us a quick intro yesterday as we were preparing for our meeting today, and it's a really exciting capability that's going to have some impact in operations in the future. It's already under evaluation in the areas of aviation, but other service areas as well. So YJ, welcome to the Satellite Book Club, and we are ready to hear your presentation. We should probably start with a sound check.
Okay, yeah, can you hear me, correct?
I can hear you clearly here.
Okay.
Yep. Thank you.
Yeah, nice to see you, everybody. It's been a while to see people in person, but it's a great opportunity to show our result in the audience. So I'm Yoo-Jung No, working at CIRA, Colorado State University, with my colleagues Steve Miller, John Haynes, Chris Simon, and Andy Heidinger, Noah Nested-Starr, and Jeff Weinrich for JPSS Aviation Initiative. For this work, I especially thanks to my collaborators and Alaska users. Yeah, it's many names here, and we have more. So today my topic is satellite cloud vertical structure products for aviation users. So this animation is from GOES-16 ABI overlaid with the GLM image for Hurricane Eta in November. And this is wonderful animation. And another example from GOES-16 ABI and GLM for severe storms over Midwest in November. So it's all satellites have been providing wonderful information about clouds and other weather phenomena. But today's topic is a 3D cloud vertical structure. Actually, satellite information is primarily cloud top view from space. So the three-dimensional cloud vertical structure information is very important for weather and aviation, weather applications especially. But it's a very challenging task for conventional satellite observations, which are mostly from passive radiometers, VIIRS and ABI-O. But our team developed a statistical cloud-based height algorithm using NASA A-Train satellite data, which is a key component to build the satellite's 3D cloud structure field. So I'm going to introduce some of our works here. So your feedback and the suggestions will be very welcome for that. So it's a briefly introduction about our new cloud-based height algorithm here. So can you see my cursor here? So we developed a statistical cloud-based height algorithm using NASA satellite data from CloudSat, radar, Calypso, LiDAR, and Aqua MODIS. CloudSat and Calypso can see through the whole cloud layers vertically, but only over a very narrow swath. And MODIS gives a wide swath observations, but only provide a vertically integrated cloud water path. So using the combinations of these all satellite data, we could drive a global statistical regressions between cloud water path from MODIS here and the geometric thickness from CloudSat radar and the Calypso LiDAR active sensor observations here. So with this statistical regression lookup table approach, once we have a cloud top and cloud water path information from any satellite sensor such as VIIRS and the ABI, first we can drive a cloud geometry thickness here, and we have a cloud top height. So we can drive cloud base height from any sensor. So we applied this algorithm first to JPSS VIIRS satellite VIIRS, assuming MPP, and validated using independent cloud set and Calypso observations. This algorithm is now operational at NOAA. We are trying to get some cloud vertical information from satellites. Still, this algorithm is still optimal for single layers, I should say. So there is another satellite cloud product we call the cloud cover layers. Actually, in our old approach, we only have a cloud top information like this. It says 2D cloud view from the space. So we can have a cloud fractions like a low-level cloud, mid-level cloud, and high-level cloud based on cloud top information only. But reality is that this is one example of a deep convection cloud. We have a vertically extended cloud layers here. So with our new approach with cloud base height algorithm, we can increase this lower-level cloud portions hidden under cloud top here. So this is a schematics from satellite. We have this is cloud layers. Only we have had a high and mid low cloud vertical layer information originally. But with our cloud base height algorithm, we have additional cloud classifications like high plus mid, mid plus low, or deep convections, high plus mid plus low. And for aviation users, we are using 5 vertical layers based on the flight levels as well. So here is a real example applied to GOES-16 ABI. So the bottom image is from ABI IR image, 11 microns over CONUS. And the vertical curtain view is from cloud set radar for this comparisons. And this part is cloud vertical layers. Actually, from cloud top information only, we only see this cyan colored high cloud layers. But of course, it's we see this deep convection part here. So with our algorithm, we can introduce this new cloud vertical layer informations for deeper part and some mid plus low cloud layers here, and the more colors you can see this one. So now this is GOES-16 ABI geocolor we all see very frequently these days. So now not just the imagery, we can see where is the low cloud fractions here with cloud and the high cloud fractions with our algorithm, and all combined cloud vertical layer information here. And these products is all available in CIRA slider here. So you can see these cloud layers from VIIRS or ABI and the Himalaya AHI too. So this is one example from, again, the slider. So geocolor plus the GLM satellite image for tropical storm ETA case. And this is cloud vertical layers corresponding this satellite image. So you can see this deep cloud part and the low cloud around here in orange colors. So now it's available in CIRA slider and the CIRA website, and we are also working on the operational display in AWIPS and NAWIPS implementations as well. For polar satellites, JPSS VIIRS imagery also available in CIRA slider, polar slider here. So with the other satellite images, This is a geo-color image. For example, the cloud top information, it's the northern hemisphere. Alaska is here, North Pole. Geometry thickness here, and the cloud base height. Of course, there's a bunch of other cloud product as well. So far, some introduction of our new cloud base and the geometry thickness and the cloud vertical layer information. So it's a sort of achievement as a cloud algorithm developer. But as you see, there are a bunch of cloud product from satellite, and I realized it's we develop new ones, but we just add some more extra to, forecasters a long list. Actually, forecasters are too busy to look at all this cloud product. Actually, we introduced this cloud vertical layer information, but as I found that forecasters too busy to look at this one. So actually, this talk is about our new approach, how to introduce satellite cloud product in more user-friendly ways. So this is a cloud vertical cross-section product we newly introduced. So we've been thinking about how we can provide this all satellite cloud products in more user-friendly ways, and participating in the NOAA Aviation Initiative organized by J. Weinrich. We introduced the cloud vertical cross-sections like this during the JPSS Cloud Alaska demonstration to promote the satellite cloud products for aviation applications. This is one example over Alaska. On the left, this is VIRS IR imagery with the flight path colored in differently here. It's Anchorage. This is one example, cloud cross sections between Bel Air to Anchorage Airport. So here is a altitude and it's a longitude here. All cloud height, top and base height colored by cloud phase. Based on user feedback, we added the temperature profiles from NUCAPS or NWP here. We have terrain information. And we also added a pilot reports, icing and the turbulence information based on user feedback here too. So we can see very active icing and turbulence over the Anchorage Airport in this case. So the product is now demonstrating in our VIRS experimental website here. So we are regularly getting user feedback through monthly telecons and emails on the online surveys from operational users and especially Alaska pilots. And continue to update our display details and the user information based on the user feedback, actually. So this is our website for this experimental product for aviation. So you can see some IR image 2D view and corresponding cross sections for different airports here, and the user and some documents information is here as well. And especially I'd like to again thank Alaska users and the collaborators for this all activities. It's actually we are working on this work as a one team. And you can click this website and you can see this IR image, and you can click one flight path like this, and you can see cloud cross sections. This is from VIRS example. So please visit this website and keep any your comments or suggestions. So actually this we started with a very small audience and just a test flight path, but we are getting more feedbacks and suggestions. And recently we got feedback from West Coast operational users, and we expanded this target area from Alaska to CONUS as well. So for CONUS case, we can add geostationary satellite observations as well. Of course, GOES-16 ABI here, one example. And this example from Chicago to New York airport, you can see it's icing is occurring over a Chicago airport in this case. So one website for Alaska, and newly we added the CONUS website as well here. Okay, so a lot of user feedback we are getting now. Sorry about that. Actually, we got a very small group, actually starting with a few people and local pilots and operational users. But now our team is bigger and bigger, and we never forced to do something for this work, but our collaborators and the pilots are getting feedback, and it's some examples how we are introducing our product in social medias and other news websites, and some pilot newsletters, and some YouTube platforms here. It's yeah, thankfully our users voluntarily do these activities. And we are getting some emails directly from the local pilots. This is one example. This is so valuable for our product evaluation. This is one example between Anchorage and the Fairbanks cross sections here. One pilot actually directly sent me an email, like his own very detailed pilot reports for the product evaluation. It's so valuable. And another our activity is develop user training materials. This is a quick guide example here. And I want to emphasize here that these documents are updated based on the user feedback. Local pilots gave or line by line or the reviews on these documents, and we are improving these materials as well. So anytime if you have any questions or suggestions, please let us know as well. So time is okay. Just briefly, we are also working on some science algorithm improvements, as well as a user engaged improvement. This is one example for improve the multi-layer cloud detection, especially low cloud. This is very important for aviation applications. So using traditional statistical approach as well, we are also using machine learning approach to improve this lower cloud detection from multi-layer scenes. So it's just one example. It's our current cloud vertical layer information. With the machine learning approach, we can introduce more deep cloud colored in purple here. And we also introduce a high plus low cloud categories colored in pink here. It's all multi-layer clouds. So this is ongoing work. And another science approach to improve nighttime cloud retrievals. Of course, at night, we don't have any visible information for cloud retrievers, but VIRS has a capability of a DMB, lunar reflectance, so we can introduce a visible observation even at night as well. So we are using this information to drive cloud geometry thickness cloud base as well as NWP, and we are now introducing DMB capability here too. So this is a brief summary about our science work. So here is a summary. So we developed a statistical cloud-based height algorithm to provide a 3D cloud structure information based on satellite observations. So algorithm is now operational at NOAA. And for more user-friendly ways to provide us some satellite cloud information, we recently introduced the cloud vertical cross sections for aviation users starting from Alaska. We are expanding this effort to CONUS, and all improvements are based on user feedback. And the ongoing science work is we are utilizing DMB for nighttime retrievals, and we're utilizing machine learning approach for multi-layer clouds. So especially I like to thank our collaborators and Alaska users, and any feedback and the collaboration for further cloud product development and the improvements will be welcome. Thank you so much.
All right, YJ, thanks for that great presentation. Thanks to you and your collaborators, developers and scientists for the work you're doing and for putting this together for us. I've got some questions and I've seen some coming on the chat. So please remain on the line if you can. We're going to get to those in just a moment. So please hang on, bear with us. There is we're going to be already the survey in the chat room that we always encourage participants to take for each of our usual Satellite Book Club sessions. I want to mention now, before folks have to leave, that we will be having another book club seminar next Thursday, usual day and time, noon Eastern time on Thursday. Dr. Bob Graben from NISL, from NSSL, will be here to discuss and present optical flow technique for wind analysis using GOES imagery. So we're sure that you'll and hope you'll be interested and able to attend that. As usual, the recordings will be available for the session if you're unable to attend. And I want to encourage you, as always, there are contacts there displayed on the screen now for Lee Byerly, Kashad, and the TowerS team for questions about the Satellite Book Club and also things related to configuring some of these satellite products that are available in your AWIP. So feel free to contact them. In fact, we encourage you to. And they also put out periodic updates for software updates and RPMs and so forth. So let's see, I'd like to get to the discussion. Why don't we start with those in the chat room, the chat session. And let's see, I see one of them was already answered. I'm sorry if we'll pick from the top here. We had a question from Tom about a link, although maybe that link has since been shared further down in the chat. So that is a link to the cloud layer slider. Could potentially be useful in NWS operations. So do we already have that link? Is that one of the links further down? I think it maybe is already there. If not, I'm going to move on to the next question. So I want to make sure we get an answer to that one. Question from Randy: what's the average latency between the time the satellite image is transmitted and the time the product is released available to users?
Oh, actually, this is a still experimental product, and I'm working at CIRA. It's not an operational institute, but actually we are getting data from the GINA broadcast, and we are processing all the cloud retrievers using CleverX at CIRA. So we have a it's a latency is it's not like operational, but it's for VIIRS case, it's 15 minutes or 15 minutes to even 120 minutes sometimes. But it's we are working on operational transition, so it'll be faster. And of course, it goes ABI case, it's much faster. It's almost a real time.
Okay, and what if for those cases where you've got the VIIRS and the ABI together, was that the 15 to 100 minutes you were referring to when you have both sensor types available?
Actually, it's for combinations of VIIRS and the ABI, and we're processing. It's once all the data level 1 original data is arrived in our machine. The VIIRS case is a little slower than ABI, so it's actually reprocessing at the same time. It's once it's any satellite data comes first.
Okay, good. Thank you for that. And let's see, I think John asked a question that was answered. I think the legend was found, so I think that one's already answered. Bill Schober points out, want to agree with Bill Schober. They're a great example of GOES and JPSS working together. I really appreciated, YJ, your sensitivity to that. While more satellite cloud products are good, at some point we get to the forecaster overload problem. So to the extent that a superior multi-sensor product that provides the best of both instruments alleviates the forecaster from having to look at too many things on the menu, especially when they're in rapid decision-making mode. So we appreciate your sensitivity to that. The forecasters do as well. Okay, let's see. So scrolling down here in the chat, what else do we have? Question from Scott Lindstrom. What are the error estimates on the cloud-based values? This was not seen in the quick.
Yeah, actually, it's a very important question. Actually, we are estimating cloud-based errors using some other source, independent cloud set and Calypso comparisons. And we have a ATBD for the details, how to compare it, how to calculate it, or the error estimate. And for the product, actually, it's a cloud-based height itself operational product. We have a quality flags as well. So if you need any more detailed information, I can provide the documents exactly.
Okay, very good. So Tom asks about the CONUS product. He didn't see any isotherms available, and is that information available?
That's a good question. Actually, it's for VIRS case, we can have NUCAPS data, promptly corresponding ones. But it's ABI case, we are just providing freezing levels and the model based, currently GFS for operational. So yeah, it's actually we added a 0 and -20 Celsius degree based on user feedback, which is very important for icing problems. So if you have more suggestions, we can add more temperature profiles based on NWP model data for ABI case so far.
Okay, we have a question also from Mike. Is there a parallel to the GOES-16 ABI Aviation Initiative?
Actually, I never heard of it, but it's starting from the JPSS VIIRS, JPSS Aviation Initiative. We are actually expanding our efforts for ABI territory. So I don't know officially there is a separate ABI Aviation Initiative.
Okay, and we have a question from Brian Mata. Are there any use cases for these products? So you told us that you were doing some collaboration with folks in the Alaska region and starting to talk to, or maybe already underway with AWC. Are there use cases in the sense of how specifically these products would be used to create to make a decision or to create a office product?
Yeah, it's we introduced this experimental approach a couple of years ago for Alaska users. So now we are getting more attentions from other operational users like AWC or other folks. So we just started some discussions for some potential collaborations with AWC. They have a GFA graphic forecast product for aviation. Of course, they have an intensive experience for this kind of cross sections based on model. So we are now looking for some collaboration to support their effort, and we want to add our satellite products. It'll be not, of course, now product, not forecast, but we hope to support this effort with our satellite observations. So it'll be soon through operational pathway.
Okay, and Bill Schober provided a response there in the chat. I think to Mike's comment that suggesting no need for a separate JPSS GOES initiatives aviation to be a satellite initiative, much the same way as river ice flooding and fire and smoke are, rather than having two adjacent stovepipes. So good suggestion, Bill. I had a question as to whether you think it would be beneficial to supplement the IR readings with microwave to help sort out whether there's precipitation and whether that has any influence on the cloud products. Has that been considered? Like
yeah,
actually, I see it now, the ATMS down there at the bottom of the slide. It's on the screen.
Great,
okay.
Yeah, great suggestion in the comments. Actually, it's it's especially Alaska regions, nighttime retrievals. It's so difficult. We have a DMB, but problem is it's all good for full moon cases. So without any sufficient moonlight, we still dependent on NWP information or IR information, which is fully saturated in deep cloud. So now we start using ATMS microwave data to get the deeper cloud information. Of course, it has coarse resolutions, but yes, I hope this addition of ATMS information will be better approach for nighttime cloud retrievers, of course.
Outstanding. And another question, I'm sorry if you hit on this one already, is there a feature in the visualization tools that would enable the user to select start and end points?
Yeah, it's a good comment. It's actually, now we start to introduce this product. It's most frequent questions. It's our user interactive display tool is available for this, but we are still thinking about that, and it's our top priority for the product demonstration. We are working on that. That's a good suggestion.
Okay, YJ, do we have any other questions? It looks like we've addressed those that are in the chat, but do want to make a last call if there's anyone who might have any follow-ups. And if not, then we want to thank YJ and her colleagues and collaborators for this presentation, and encourage folks who have an interest to reach out to her and her team. Her contact information is there. She said they're welcoming evaluators who can provide feedback and shape the evolution of these products. And as they get further along, Tara's team is eager, ready, and interested in helping transition the more mature capabilities towards operations. So we're going to have one eye on this, and two when possible, and appreciate you coming to brief both the end users on the call as well as the development organizations and our partners at NESDIS. So with that, thanks again, YJ, to you and your coworkers.
Okay.
And also just a reminder again, our next satellite book club meeting will be Thursday the 4th at noon, same time as usual. And everyone have a good week. Look forward to seeing you then. Thank you.
Thank you so much.
Thanks, YJ.